So here we have another example dealing with recoil. So in this example, we're going to use momentum conservation, and we're going to see why the rifle recoils when it's fired. A marksman holds a 3 kilogram rifle loosely, so we can ignore any horizontal external forces acting on the rifle bullet system. He fires a bullet of mass 5 grams horizontally with a speed of 300 meters per second. So what's the recoil speed of the actual rifle? That's our first part, and then we're being asked, what are the final kinetic energies of the bullet and the rifle? So let's write down the values that we have first. We know that the mass of the rifle is 3 kilograms, and we know that the mass of the bullet is 5 grams. And let's convert this to kilograms because we want to be working with the same units. So in kilograms, this will be 5 times 10 to the negative 3 kilograms. And then the last value that we're given is the velocity of the bullet, which is 300 meters per second. So I'm going to draw a little before and after diagram to better understand this. So for our before, draw the little man holding the rifle. And we have no force being exerted this way because it's before he even fires it. And then after, draw the little man again. And now, the bullet is going this way at 300 meters per second. And we know its mass. And we know the man's mass. So let's try to solve part A. What's the recoil speed of the actual rifle? So we know that the initial momentum is going to be equal to the final momentum in this case. So we do know that the initial momentum is 0 because there's no forces acting here. So for the 0, and now here we would do the mass of the rifle times the velocity of the rifle plus the mass of the bullet times the velocity of the bullet. So the only thing we're missing is the velocity of the rifle. So here we know it's 3 kilograms. And then we know that this here is 5 times 10 to the negative 3 kilograms. And then the velocity of the bullet is 300 meters per second. So once we solve all of this and isolate our first velocity of the rifle, it's negative 0.500 meters per second. And it's significantly smaller than that of the bullet because it's going in the opposite direction. And now we can also try to find the kinetic energy. So for the kinetic energies, let me clean up some space here. Okay, so we can find the kinetic energy of the rifle, and we can find the kinetic energy of the bullet. Let's do the kinetic energy of the bullet first. So it's going to be half of the bullet's mass times the velocity squared. And that gives us 225 joules. And now for the rifle, it's going to be half times the mass of the rifle times its velocity squared. And that gives us 0.375 joules. Once again, the kinetic energy of the rifle is significantly smaller in this case.